Okay, you are looking live at I guess this is in San Jose, California, with the much anticipated Nvidia GTC keynote. Oh, by
Gee,
the way, I'm Brent Leary.
and I have no other text to add other than I'm Paul Greenberg.
And we are the CRM players, but we're not the CRM players the way you usually see us on Thursdays because it's Monday.
Oh my God,
Yeah,
another universal conundrum.
yeah, just exactly that. But anyway, this is the first watch party we've done in 2024. And it's not even like a CRM or a CX kind of company. How did this happen?
I actually don't know because the last watch party we attempted was the Apple one, and we got dinged for that by YouTube. They considered that a violation of what I have no idea.
Yeah, I don't know, but and we don't know what'll happen with this, but at least for the time being, we are anxiously awaiting the beginning of the Nvidia GTC conference 2024 keynote with Jensen Huang. You know, everybody, I have to say this. We've gone to a lot of events over the decades at this point.
Mm-hmm.
And we've seen like Dreamforce is probably the biggest event. I think they maxed out at 170,000, and everybody. I mean, that the lead up to that, everybody's talked about it. Now, I don't expect this to be as big in terms of the number of people, but the anticipation for this because of what Nvidia means to the AI era, if the whole foundation of all these companies that we deal with and then some are built on the chips that these folks are producing. The build up to this has been really interesting.
Well, I mean, it's bizarre too. It's okay. I'm a gamer, of course, and I have been for a long time, and I use NVIDIA GPUs. I use NVIDIA cards. And for me, of course, it's the only way to go. I'm not an AMD guy in the slightest, and these are powerful cards, and you can see like how they render things in almost real time at enormous frame rates and so on and so forth. And yet the chips that these guys are developing for like Gen AI and so on I mean, basically they're the power one chip embedded in whatever kind of card they use. I would put it this way, probably exceeds the power of their best gaming GPU by thousands of times. And you're talking about heavy duty power here. I
Well,
mean,
but the funny thing is, those AI, the GPU AI chips they were making. Remember, I did a stump the Godfather on you, and even you were kind of surprised at how big. We were talking what 70-pound chips.
yeah, 70-pound chips. That's
That's kind of crazy.
highly caloric.
Yeah. Yeah, and so anyway, in all of the companies that we tend to, follow and attend events and even work with in some instances, they all seem to have some level of partnership when it comes to what they're trying to do with their platforms with Gen AI. I mean, everyone, even last week, Oracle, and during their earnings call, announced a partnership.
So what? We have Salesforce, Oracle, ServiceNow,
Adobe, of course.
Adobe.
I
A
know what
couple
I
others.
haven't heard of. Did SAP announce anything? Microsoft, of course, they're working with.
Microsoft. I think
Yeah.
SAP might have. God, that guy's just creeping me out.
This is amazing, folks. We have the sound turned down until the keynote, but this is on the main stage, and this guy, I don't know what the hell he's doing, but it is captivating me.
Well, I love the visuals here, but he's just freaking me out, man.
Yeah, he is kind of like all he's doing. He's not saying a word. He's just
And he has that weird little smile on his face the whole time and he's holding this tablet, and he doesn't seem to be writing on it. He just seems to be holding a pen to it without moving
he's
it.
got to be making that fluid movement. And look at that. I mean, that's some interesting stuff. By the way, hello, Alan. Yeah, 70-pound chips are highly caloric. Yeah.
I would say that is probably going to be the best takeaway we come up with.
As long as they're not buffalo chips,
Oh God, no. Oh man, taking it right down the sewer immediately.
Well, it took me a minute or two to get warmed up.
Yeah, a little longer than usual. We're good though.
But we are. I cannot wait to see what's going to happen. I mean,
To be honest, I can't wait for that guy to leave the stage.
Well, you know what? Let's turn the sound on because that stuff's just stopped. So let me see if I can bring the sound up here.
Our show is about to begin.
Oh, talk about perfect timing.
Wow.
Timing.
You have it down, Mr. Producer.
Rare form.
Mr. Producer has it down.
That is the artist. Who? First of all, who is LinkedIn user, and then who is
identify yourself, please?
What's the artist's name?
So apparently, that artist is drawing what we're seeing on the screen. I'm assuming is what LinkedIn user is talking about.
Okay, here's some theatrics going on. Hey, Rafiq, thank you,
thank you, sir.
Yep. This is so dramatic.
I'm going to be interested in seeing how it overlaps with what we do.
I am very interested in seeing that. And any of our guys join Jensen on stage. I'm looking out for that too.
Yeah.
I am a visionary. Illuminating galaxies to witness the birth of stars.
This is kind of cool. I'm already liking it.
I'm wondering if that's the James Webb Telescope.
Oh, we tagged the artist.
Okay, our
cool.
understanding
Thank
of
you.
Extreme weather events. I am a helper, guiding the blind through a crowded world.
Wow.
I was thinking about running to the store.
And giving voice to those who cannot speak.
Do not make me laugh.
Wow.
You like that?
I am a transformer, harnessing gravity to store renewable power.
Jesus Christ.
And paving the way towards unlimited clean energy for us all. I am a trainer, teaching robots to assist.
Whoa.
To watch out for danger. And help save lives. I am a healer, providing a new generation of cures and new levels of patient care.
Doctor, that I am allergic to penicillin. Is it still okay to take the medications?
Definitely. These antibiotics don't contain penicillin.
Yikes, that looks kind of like her, doesn't it?
I am a navigator, generating virtual scenarios to let us safely explore the real world and understand every decision. I even helped write the script.
Wow.
Breathe life into the words en muchos idiomas y escribí la música.
Man, this is so well done.
You're not kidding.
AI, brought to life by Nvidia, deep learning, and brilliant minds.
That is
everywhere.
That's an opening.
Yeah. That actually moved me. It actually literally moved me and inspired me to.
That
literally.
Please welcome to the stage Nvidia founder and CEO Jensen Huang.
That's AI generated music too.
All the CX company events that we've gone to, none of them can touch this opening at least.
No.
That was brilliant.
Welcome to GTC.
Damn.
I hope you realize this is not a concert. You have arrived at a developers conference. There will be a lot of science described, algorithms, computer architecture, mathematics.
Yeah. Not. They didn't get the cue apparently.
No.
I sensed a very heavy weight in the room all of a sudden. Almost like you were in the wrong place. No, no conference in the world is there a greater assembly of researchers from such diverse fields of science, from climate tech to radio sciences, trying to figure out how to use AI to robotically control MIMOs for next generation 6G radios, robotics, self-driving cars, even artificial intelligence.
Even.
Even artificial
I
intelligence.
think that was a joke.
His jokes are not working with this crowd.
I noticed a sense of relief there all of a sudden.
That was
Also,
funny how
He's
bad
like
you
0
said
for
it.
3.
conference is
No,
represented
not his fault.
by
I
some
think this is
amazing
the
No.
audience. Audience's literal
list-
lack of awareness, I think.
This is not the attendees. These are the presenters.
Damn.
Holy crap. Well,
what's
there's
amazing
Oracle,
is this.
Microsoft,
Adobe.
ServiceNow,
All of
That's-
my friends,
Adobe,
close friends,
That's
Michael Dell is sitting right there, in the IT industry.
SAP. They're there.
see, he's able to call out the CEOs of these companies
All of the
that are
friends I
there.
grew up with in the industry. If you take away that list,
All of the big ones are there.
this is
All
what's
the big
amazing.
5, big 6. I mean.
These are the presenters of the non-IT industries using accelerated computing to solve
There's
problems that
LinkedIn.
normal computers can't.
Yeah.
It's
PayPal,
represented
Lockheed Martin.
The logos
in
of
life
this.
sciences,
Amazing.
healthcare,
Well, it's
genomics,
not surprising actually.
transportation, of course.
Oh, these are just the
retail,
speakers though.
Logistics, manufacturing, industrial. The gamut of industries represented is truly amazing. And you're not here to attend only, you're here to present, to talk about your research. $100 trillion of the world's industries is represented in this room today.
What?
This is absolutely amazing.
How did we get 100 trillion?
There is
don't know.
absolutely something
Can't be right.
happening. There is something going on. The industry is being transformed, not just ours. Because the computer industry, the computer is the single most important instrument of society today. Fundamental transformations in computing affects every industry. But how did we start? How did we get here? I made a little cartoon for you. Literally, I drew this. In one page, this is Nvidia's journey. Started in 1993. This might be the rest of the talk. 1993,
Yeah,
this
not
is our
getting-
journey. We were founded in
Nope.
1993. There are several important events that happened along the way. I'll just highlight a few. In 2006, CUDA, which has turned out to have been a revolutionary computing model, we thought it was revolutionary then. It was going to be an overnight success, and almost 20 years later, it happened.
Huh. Is he waiting for people to laugh? Because nobody's laughing.
No.
2 decades later.
This is weird.
In 2012, AlexNet, AI and CUDA made first contact. In 2016, recognizing the importance of this computing model, we invented a brand new type of computer. We called it DGX-1. 170 teraflops in this supercomputer. 8
Teraflops.
GPUs
Wow.
connected together for the very first time.
How big is
I
a teraflop?
hand-delivered the very first DGX-1 to a
know.
startup located in San Francisco called OpenAI.
He got a clap for that one.
Probably the audience are from the employees of OpenAI.
DGX-1 was the
The
world's
audience.
first AI supercomputer. Remember, 170 teraflops. 2017,
Gotta look up
the
teraflops.
transformer arrived. 2022, ChatGPT captured the world's imaginations, have people realize the importance and the capabilities of artificial intelligence. And 2023, generative AI emerged and a new industry begins. Why? Why is a new industry? Because the software never existed before. We are now producing software, using computers to write software. producing software that never existed before. It is a brand new category. It took share from nothing. It's a brand new category. And the way you produce this software is unlike anything we've ever done before. In data centers, generating tokens, producing floating point numbers at very large scale.
Flop.
As if
Floating.
in the beginning
FLOP.
of this last industrial revolution,
Floating point somewhere
when
in
people
there.
realized that you would set up factories, apply energy to it, and this invisible, valuable thing called electricity came out, AC generators. And 100 years later, 200 years later, we are now creating new types of electrons, tokens, using infrastructure we call factories, AI factories, to generate this new, incredibly valuable thing called artificial intelligence. A new industry has emerged.
Yeah, floating
Well,
point.
We're going to talk about
Wow.
many things about this new industry.
It's big, Ed. You're right.
We're going to talk about how we're going to do computing next. We're going to talk about the type of software that you build because of this new industry, the new software, how you would think about this new software. What about applications in this new industry?
Yeah, now we're talking.
And then maybe what's next? And how can we start preparing today for what is about to come next? Well, but before I start, I want to show you the soul of Nvidia, the soul of our company, at the intersection of computer graphics, physics, and artificial intelligence, all intersecting inside a computer in Omniverse, in a virtual world simulation. Everything we're going to show you today, literally everything we're going to show you today, is a simulation, not animation. It's only beautiful because it's physics. The world is beautiful. It's only amazing because it's being animated with robotics.
Is that what he has his
Being
PhD in
animated with
physics?
artificial intelligence. What you're
What?
about to see all day
Does he have his PhD in physics or
is
something?
completely
I don't
generated,
know.
completely simulated in Omniverse. And all of it, what you're about to enjoy is the world's first concert where everything is homemade.
Unbelievable. This audience is
This
just,
audience is so dry. I mean, damn.
Everything
Wow.
is homemade.
I mean,
You're
he's
about to
what he's
watch
saying is amazing.
Home videos. So sit back and enjoy yourself.
They need one of those clap now things. So this is all simulated.
Yep. Every single one of these things is generated somehow.
Wow, that looks beautiful. Wow, look at that.
He's right. It's all physics. Keep in mind, the music is generated by the AI too.
Everything, yeah.
Yep. But this is literally pure physics, what we're looking at.
I wonder if the audio and video were created in sync at the same time, or did one was used to create the other?
It'd be interesting to find out, I'll tell you that.
This is really something.
How would it know what a SIM-ready warehouse is?
I don't know.
And SIM-ready was capital S, capital R, and one word. Seems peculiar.
That looked like it was an Adobe Premiere Pro.
Yeah.
Wow, that is some really beautiful stuff. Look at that.
Yeah, and just think the gamers get a little tiny piece of that.
God, I love Nvidia.
But you do.
Jeez.
Accelerated computing has reached the tipping point. General purpose computing has run out of steam. We need another way of doing computing so that we can continue to scale, so that we can continue to drive down the cost of computing, so that we can continue to consume more and more computing while being sustainable. Accelerated computing is a dramatic speed up over general purpose computing. And in every single industry we engage, and I'll show you many,
Hey,
the
Larry.
impact
Larry.
is dramatic. But in no industry is it more important than our own. The industry of using simulation tools to create products. In this industry, it is not about driving down the cost of computing, it's about driving up the scale of computing. We would like to be able to simulate the entire product that we do completely in full fidelity, completely digitally, in essentially what we call digital twins. We would like to design it.
Is Ray
build
there?
it, simulate it, operate it
No, it's clones are.
completely digitally. In order to do that, we need to accelerate an entire industry. And today, I would like to announce that we have some partners who are joining us in this journey to accelerate their entire ecosystem so that we can bring the world into accelerated computing. But there's a bonus. When you become accelerated, your infrastructure is CUDA GPUs. And when that happens, it's exactly the same infrastructure for generative AI. And so I'm just delighted to announce several very important partnerships. They're some of the most important
Okay,
companies
here we
in the
go.
world.
Here we go.
ANSYS does engineering simulation for what the world makes. We're partnering with them to CUDA accelerate the ANSYS ecosystem, to connect ANSYS to the Omniverse digital twin. Incredible. The thing that's really great is that the install base of NVIDIA GPU accelerated systems are all over the world, in every cloud, in every system, all over enterprises. And so the applications they accelerate will have a giant install base to go serve. End users will have amazing applications. And of course, system makers and CSPs will have great customer demand. Synopsys. Synopsys is NVIDIA's literally first software partner. They were there in the very first day of our company. Synopsys revolutionized the chip industry with high-level design. We are going to CUDA accelerate Synopsys. We're accelerating computational lithography, one of the most important applications that nobody's ever known about. In order to make chips, we have to push lithography to the limit. NVIDIA has created a library, a domain-specific library, that accelerates computational lithography incredibly. Once we can accelerate and software define all of TSMC, who is announcing today that they're going to go into production with NVIDIA cuLitho. Once it's software defined and accelerated, the next step is to apply generative AI to the future of semiconductor manufacturing, pushing geometry even further. Cadence builds the world's essential EDA and SDA tools.
Just found out about
we
this.
We also use Cadence. Between these three companies, ANSYS, Synopsys, and Cadence, we basically build NVIDIA. Together, we are CUDA accelerating Cadence. They're also building a supercomputer out of NVIDIA GPUs so that their customers could do fluid dynamic simulation at 1,000 times scale. Basically, a wind tunnel in real time. Cadence Millennium, a supercomputer with NVIDIA GPUs inside. A software company building supercomputers. I love seeing that. Building Cadence co-pilots together. Imagine a day when Cadence could, Synopsys, ANSYS, tool providers, would offer you AI co-pilots so that we have thousands and thousands of co-pilot assistants helping us design chips, design systems. And we're also going to connect Cadence Digital Twin Platform to Omniverse. As you can see the trend here, we're accelerating the world's CAE, EDA, and SDA so that we could create our future in digital twins. And we're going to connect them all to Omniverse, the fundamental operating system for future digital
So
twins.
Omniverse is their metaverse, basically, right?
One of the
Yeah,
industries
well,
that
yeah, a
benefited
little more, I
tremendously
think.
from
Yeah,
scale,
but that's
and you
the
know,
marketing.
you all know this one
Yeah.
very well, large language models.
Here we go.
Basically, after the transformer was invented, we were able to scale large language models at incredible rates, effectively doubling every 6 months.
Peter flops.
Now, how is it possible that by doubling every 6 months, that we have grown the industry, we have grown the computational requirements so far? And the reason for that is quite simply this. If you double the size of the model, you double the size of your brain, you need twice as much information to go fill it. And so every time you double your parameter count, you also have to appropriately increase your training token count. The combination of those two numbers becomes the computation scale you have to support. The latest, the state-of-the-art OpenAI model is approximately 1.8 trillion parameters. 1.8 trillion parameters required several trillion tokens to go train.
Wow.
So a few trillion parameters on the order of, a few trillion tokens on the order of, when you multiply the two of them together, approximately 30, 40, 50 billion, quadrillion floating point operations per second.
Does
Now, when
anybody
someone
really
uses CO
understand what
math,
that
let me
number
just hang-
means?
Hang with me.
No, when you
You
get
have
if
30
the,
billion,
frankly, if you get
quadrillion.
after 100,000, I'm
Quadrillion is like
kind of
a peta.
lost.
And so if you had a petaflop GPU, you would need 30 billion seconds to go compute, to go train that model. 30 billion seconds
So
is
a petaflop
approximately
would be
1,000 years.
30
Right,
billion
that-
seconds is
Well,
1,000 years. Did you hear
years-
what he just
Yeah.
It's worth it.
I'm saying 1,000 trillion GPUs, floating point operations is
I'd like
per
to do it
second is
sooner,
a
but it's worth
petaflop.
it.
1,000 trillion.
This is like gibberish at this
Usually
point.
my answer when most people
It's
tell
too
me, "Hey,
much.
how long is it going to take to do something? It's gonna-
I
20
agree,
years."
LinkedIn user.
It's worth it.
It's a real lot.
But can we do it next week? And so
This really is a
1,000
developers
years,
conference.
1,000 years. So what we need
It's definitely different than what we're used
are
to.
bigger GPUs.
Well, I mean, I can't really be much of an analyst with it other than
We
just sort of
recognized
watch it
this early on,
because
and we realized
it's
that
beyond
the
my
answer is to put a whole
technical
bunch of
know-how.
GPUs together.
I'm
Oh
waiting.
my God, no,
Yeah.
look at that. That
Along the
chip
way,
is an
like
8
inventing
millionth of
tensor
a
cores,
off.
advancing NVLink so that we could create essentially virtually
Yes, it
giant
was.
systems
Ishtar.
and connecting them
That's
all
pretty
together
good.
with
The
amazing
fact that you
networks.
know Ishtar
A company called
says a lot
Mellanox
about
and
you, Al.
Broadband, so that we could create these giant systems. And so DGX-1 was our
The
first version,
biggest
but it wasn't
movie
the
flop
last.
of all time.
We built supercomputers all along the way. In 2021,
See, the
we had
H100 is there,
4,500
that
GPUs or so.
chip that
And then
Right.
I
in
remember when I forwarded you that
2022,
article about
one of
the
the
other chip
largest
that's
AI
like,
supercomputers in the world
what was it,
is to come online
300,000 times or 3,000
EOS.
times more powerful in the
And as we're
H100?
building these things,
But look at the difference between
we're trying to
2021
help the
and
world build
2020.
these things.
That's only 2 years.
And in order to
I
help the
know.
world build these
The,
things, we got to build them
the
first.
difference in these chips are
Build the chips,
amazing.
the systems, the networking, all of the software necessary to do this. You should see these systems. Imagine writing a piece of software that runs across the entire system, distributing the computation across
Jeez.
thousands of GPUs, but inside are thousands of smaller GPUs. Millions of GPUs to distribute work across all of that and to balance the workload.
I'm
so that
literally
energy efficiency,
buying
best
his
computation
top
time,
of the line
cost down. And so
gaming
those
card, and I'm sitting here
those
worrying about,
fundamental
is there
innovations
coil wine? And this guy's
is what
talking
got us.
about millions and trillions of
here we are
GPUs inside of GPUs.
As we
And I'm
see the
thinking about,
miracle of
does this one make, does
ChatGPT
this
emerge in front of
thing
us,
make
we
noise?
also realize
Right.
we have
I'm thinking
a
this
long way
sounds
to
like
go.
a lot like Carl
We
Sagan.
need even larger
Billions and
models.
billions. Now it's trillions
We're going
and
to train
trillions.
it with multimodality data, not just text on the internet, but we're going to train it on text and images and graphs
And
and
video.
charts.
Yeah.
And just as we learn
Hmm.
watching TV And so there's going to be a whole bunch of watching video so that these models can be grounded in physics, understands that an arm doesn't go through a wall. And so these models would have common sense.
You're right,
By
Alan.
watching
But it's
a
interesting.
lot of the world's video combined with a lot of the world's languages.
So these machines are
They'll
going to be
use things
watching
synthetic
videos like we
data
did,
generation, just
but
as
at
you and I
scale.
do. When we try to learn, we might use our imagination.
Yeah, but it's basically they're
Simulate
saying the
how it's
machines
gonna
are going to try
end
to
up.
understand the
Just like
physics of it.
I did when I was preparing for this
Or I'm just
keynote.
trying to understand how somebody
Simulating all
shuffle
of that.
dances.
He's
I hope
still
it's
looking
gonna
for a
turn out.
joke, a laughter.
Forget your audience, man.
Yeah,
If
yeah,
you're
forget 'em,
smart,
yeah.
just talk to one of your machines. You'll be better off.
These are I hate to say these are eggheads. They're
As
not.
I
They
was
don't have a lot of
simulating how this
personality
keynote
in
was
that
going to turn out,
audience.
somebody did say
Apparently not. Well, it
that
certainly
another
don't get his
performer
jokes.
And if they don't get them,
did her performance completely on a
Well,
treadmill
actually, we get them. I don't know what.
so that
not
she
that
could be in
hard.
Well, he
shape
has
to deliver
personality.
it with full energy. I didn't do that.
all right, there we go.
If I get a little winded about 10 minutes into this, you know what happened. And so where were we? We're sitting here using synthetic data generation. We're going to use reinforcement learning. We're going to practice it in our mind. We're going to have AI working with AI, training each other, just like student and teacher debaters. All of that is going to increase the size of our model. It's going to increase the amount of data that we have, and we're going to have to build even bigger GPUs.
Wow,
Hopper is fantastic,
it's just crazy.
but we need bigger GPUs.
We need more cowbell.
And so, ladies and gentlemen, I would like to introduce you to a very, very big GPU.
Oh, he's bringing on the new GPU now. Okay,
Listen to this.
well they're into that.
Named after David Blackwell,
Who's that?
mathematician,
Okay.
game theorists, probability. We thought it was a perfect name. Blackwell, ladies and gentlemen, enjoy this.
It would have been cool if he named after Prince or Doctor Who or something like that.
208 billion transistors. $20 petaflops of AI performance.
I love it. I love this, the way they're presenting this.
Terminator Salvation.
Super chip.
Wow. 80 petaflops of AI performance.
InfiniBand Super, Nick.
They're actually running the text a little too fast.
I don't think they expect you to actually read all that.
I'm trying to.
I love the sound effects too.
Wow. I think I saw it said 8 ports at 1.8 terabytes of something. 1.8 trillion terabytes of something. I mean,
72 Blackwell GPUs fully connected by
Nvidia link, NV link. 1.8
Trillion camera.
and exaflops.
Yeah.
1.4 exaflops. That's 1,000 petaflops, I think.
800 gigabits throughput. Yeah. Wow.
Quantum. This is quantum. Now we're into quantum computing.
So it reminds me of like NCIS with that.
Yeah. Wow. What in the hell is that? That's everything together, I guess. Full data center with
32,000 GPUs. Wow. Well, that got a rise out of them.
holy God, the scale on that is insane.
Blackwell is not a chip. Blackwell is the name of a platform. People think we make GPUs, and we do, but GPUs don't look the way they used to. Here's the if you will, the heart of the Blackwell system. And this inside the company is not called Blackwell, it's just a number. And this is Blackwell sitting next to, this is the most advanced GPU in the world in production today.
All right.
This is Hopper. This is Hopper. Hopper changed the world. This is Blackwell.
Dun, dun, dun.
Not much bigger.
No, but it does all that stuff.
It's okay, Hopper.
That's funny.
You're very good. Good boy.
Good boy, really.
Yeah. This baby.
208 billion transistors, and so you could see,
wow.
I can see there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second, so that these two sides of the Blackwell chip have no clue which side they're on. There's no memory locality issues, no cache issues. It's just one giant chip. And so when we were told that Blackwell's ambitions were beyond the limits of physics, the engineer said, so what? And so this is what
so what?
And so this is the
listening
Blackwell
to Liz
chip, and it goes into two types of systems. The first one is form fit function compatible to Hopper. And so you slide on Hopper and you push in Blackwell. That's the reason why one of the challenges of ramping is going to be so efficient. There are installations of Hoppers all over the world, and they could be the same infrastructure, same design, the power, the electricity, the thermals, the software, identical, push it right back. And so this is a Hopper version for the current HGX configuration. And this is what the second Hopper looks like this. Now this is a prototype board, and Janine, could I just borrow? Ladies and gentlemen, Janine Paul.
Who's she?
I have no idea.
And so this is a fully functioning board, and I'll just be careful here. This right here is, I don't know, $10 billion. The second one's 5. It gets cheaper after that. So any customers in the audience, it's okay. All right, but this one's quite expensive. This is the bring up board, and the way it's going to go to production is like this one here. Okay, and so you're going to take
got two eyes, a nose, and a mouth.
Two Blackwell dies, two Blackwell chips, and 4 Blackwell dies connected to a Grace CPU. The Grace CPU has a super fast chip-to-chip link. What's amazing is this computer is the first of its kind where this much computation, first of all, fits into this small of a place. Second, it's memory coherent. They feel like they're just one big happy family working on one application together. And so everything is coherent within it. Just the amount of, you saw the numbers. There's a lot of terabytes this and terabytes that. But this is a miracle. This is let's see, what are some of the things on here? There's NVLink on top, PCI Express on the bottom. On your, which one is mine and your left? One of them, it doesn't matter. One of them is a CPU chip-to-chip link. It's my left or your, depending on which side. I was trying to sort that out, and I just kind of doesn't matter.
Amen, Alan.
Hopefully it comes plugged in. So
I'm working with bifurcated brain.
Okay, so this is the Grace Blackwell system.
Grace Blackwell. I got to look her up. I've never heard of her.
Well, no, not a person. David Blackwell and
Oh,
other
David
There's
chip,
more.
and the other chip is the Grace chip. I don't
So
know
it
who that's
turns
named
out-
after or
it
what's
turns
that
out-
named after.
All of the specs is fantastic, but we need a whole lot of new features in order to push the limits beyond, if you will, the limits of physics. We would like to always get a lot more X factors. And so one of the things that we did was we invented another transformer engine, the second generation. It has the ability to dynamically and automatically rescale and recast numerical formats to a lower precision whenever it can. Remember, artificial intelligence is about probability. And so you kind of have, 1.7, approximately 1.7 times approximately 1.4 to be approximately something else. Does that make sense? And so the ability for the mathematics to retain the precision and the range necessary in that particular stage of the pipeline, super important. And so it's not just about the fact that we designed a smaller ALU. The world's not quite that simple. You've got to figure out when you can use that across a computation that is thousands of GPUs. It's running for weeks and weeks on weeks, and you want to make sure that the training job is going to converge. And so this new transformer engine, we have a 5th generation NVLink. It's now twice as fast as Hopper, but very importantly, it has computation in the network. And the reason for that is because when you have so many different GPUs working together, we have to share our information with each other. We have to synchronize and update each other.
Jeez.
And every so often, we have to reduce the partial products and then rebroadcast out the partial products that
So
some
it's
of the partial
basically a
products
smart
got to
link.
everybody else.
Mm-hmm.
And so there's a lot of what is called all reduce and all to all and all gather. It's all part of this area of synchronization and collectives so that we can have GPUs working with each other. Having extraordinarily fast links and being able to do mathematics right in the network allows us to essentially amplify even further. So even though it's 1.8 terabytes per second, it's effectively higher than that. And so it's many times that of Hopper. The likelihood of a supercomputer running for weeks on end is approximately 0. And the reason for that is because there's so many components working at the same time. The probability of them working continuously is very low. And so we need to make sure that whenever there is we checkpoint and restart as often as we can. But if we have the ability to detect a weak chip or a weak node early, we can retire it and maybe swap in another processor. That ability to keep the utilization of the supercomputer high, especially when you just spent $2 billion building it, is super important.
Jeez.
And so
Yeah, I mean, I guess the
in
one thing
a
that does,
RAS engine,
I mean,
a
it's early yet,
reliability
but
engine
somewhat
that does 100%
limiting will
self-test
be the cost. I
in
mean, the
system
costs
test
sounds, the numbers
every
he's throwing out
single
are just
gate,
Yeah.
every single
beyond
bit of
staggering. They're
memory
not normal numbers.
And
the
I haven't heard
Blackwell
anything
chip
about power
and all the
consumption
memory
yet
that's
either.
connected to it. It's almost as if we shipped with every single chip its own advanced tester that we test our chips with. This is the first time we're doing this. Super excited about it. Secure AI.
A nice polite clap for security.
Only this conference do they clap for RAS. The secure AI. Obviously, you've just spent hundreds of millions of dollars creating a very important AI, and the code, the intelligence of that AI.
He's definitely
is
talking
encoded
to a
in the
very
parameters.
small audience.
You want to make
companies
sure that on
that
the
can
one
afford
hand
to
you
do
don't
this
lose it.
stuff.
On the other hand,
Yeah.
it doesn't get contaminated. And so we now have the ability to encrypt data, of course, at rest, but also in transit and while it's being computed. It's
Jeez.
all encrypted. And so we now have the ability to encrypt in transmission. And when we're computing it, it is in a trusted environment, trusted engine environment. And the last thing is decompression. Moving data in and out of these nodes when the compute is so fast becomes really essential. And so we've put in a high line speed compression engine and effectively moves data 20 times faster in and out of these computers. These computers are so powerful, and there's such a large investment. The last thing we want to do is have them be idle. And so all of these capabilities are intended to keep Blackwell fed and as busy as possible. Overall, compared to Hopper, it is 2.5 times the FP8 performance for training per chip. It also has this new format called FP6, so that even though the computation speed is the same, the bandwidth that's amplified because of the memory, the amount of parameters you can store in the memory is now amplified. FP4 effectively doubles the throughput. This is vitally important for inference. One of the things that is becoming very clear is that whenever you use a computer with AI on the other side, when you're chatting with the chatbot, when you're asking it to review or make an image, remember, in the back is a GPU generating tokens. Some people call it inference, but it's more appropriately generation. The way that computing is done in the past was retrieval. You would grab your phone, you would touch something, some signals go off, basically an email goes off to some storage somewhere. There's pre-recorded content. Somebody wrote a story, or somebody made an image, or somebody recorded a video. That pre-recorded content is then streamed back to the phone and recomposed in a way based on a recommender system to present the information to you. You know that in the future, the vast majority of that content will not be retrieved. And the reason for that is because that was pre-recorded by somebody who doesn't understand the context, which is the reason why we have to retrieve so much content. If you can be working with an AI that understands the context, who you are, for what reason you're fetching this information, and produces the information for you just the way you like it, the amount of energy we save, the amount of networking bandwidth we save, the amount of wasted time we save will be tremendous. The future is generative, which is the reason why we call it generative AI, which is the reason why this is a brand new industry. The way we compute is fundamentally different.
Man, I love the way he just broke that down.
We created a processor for the generative AI era. And one of the most important parts of it is content token generation. We call it, this format is FP4. Well, that's a lot of computation. 5x the token generation, 5x the inference capability of Hopper seems like enough.
But
why stop there? The answer is it's not enough, and I'm going to show you why. I'm going to show you why. And so we would like to have a bigger GPU, even bigger than this one.
jeez.
And so we decided to scale it. And notice, but first, let me just tell you how we've scaled. Over the course of the last 8 years, we've increased computation by 1,000 times. 8 years, 1,000 times. Remember, back in the good old days of Moore's Law, it was 2x, well, 5x every, 10x every 5 years. That's easiest math. 10x every 5 years, 100 times every 10 years. 100 times every 10 years in the middle, in the heydays of the PC revolution. 100 times every 10 years. In the last 8 years, we've gone 1,000 times. We have 2 more years to go. And so that puts it in perspective.
Jeez.
The rate at which we're advancing computing is insane, and it's still not fast enough, so we built another chip. This chip is just an incredible chip. We call it the NVLink switch. It's 50 billion transistors. It's almost the size of Hopper all by itself. This switch chip has 4 NVLinks in it, each 1.8 terabytes per second, and it has computation in it, as I mentioned. What is this chip for? If we were to build such a chip, we can have every single GPU talk to every other GPU at full speed at the same time. That's insane. It doesn't even make sense.
It doesn't to me.
But if you could do that, if you can find a way to do that and build a system to do that, that's cost effective. That's cost effective. How incredible would it be that we could have all these GPUs connect over a coherent link so that they effectively are one giant GPU? Well, one of the great inventions in order to make it cost effective is that this chip has to drive copper directly. The SerDes of this chip is just a phenomenal invention so that we could do direct drive to copper. And as a result, you can build a system that looks like this. Now this system is kind of insane.
Kind of.
This is one DGX. This is what a DGX looks like now. Remember, just 6 years ago, it was pretty heavy, but I was able to lift it. I delivered the first DGX-1 to OpenAI, and the researchers there. It's on, the pictures are on the internet, and we all autographed it. If you come to my office, it's autographed there. It's really beautiful. But you could lift it. This DGX, that DGX, by the way, was 170 teraflops. If you're not familiar with the numbering system, that's 0.17 petaflops.
Yeah, that's
so
helpful.
720.
Thanks for that.
Yeah.
The first one I delivered to
Oh, that
OpenAI,
works.
Yeah, that was really helpful.
You can round it up to 0.2, won't make any difference. And back then it was like, wow, 30 more teraflops. And so this is now 720 petaflops, almost an exaflop for training, and the world's first 1 exaflops machine in one rack.
Yeah, he's like completely gone into orbit, for me at least.
Yeah, I'm right there with you.
Just so you know, there are only a couple, 2-3 exaflops machines on the planet as we speak. And so this is an exaflops AI system in one single rack. Well, let's take a look at the back of it. So this is what makes it possible. That's the back, that's the back, the DGX MV Link spine. 130 terabytes per second goes through the back of that chassis. That is more than the aggregate bandwidth of the internet.
That's crazy. The audience is literally clapping because they don't know what to make of it. That's literally that kind of clap, like,
And
Yeah.
everything to everybody within a second.
I mean, he's speaking
And
so big,
so
it's hard to
have
keep up.
5,000
Exactly.
cables, 5,000 NV Link
the
cables.
staggering nature of what he's
Total
saying
mile.
is clear, but what
This is
he's
crazy
actually
because
saying,
we
I
had
don't
to
really
use
know.
Optics. We would
Because
have to use
right now I'm
optics
wondering,
timers.
okay, this is
And those
amazing, and it
transceivers
really
retimers
is
alone
phenomenal.
cost
Technically, what they've
20,000
done, like to a
watts.
degree that my
2
mind has a hard time
kilowatts
even
transceivers alone
uh,
just to drive
wrapping
the NV
around.
line.
What
As a
would you
result,
use it for? I'd like to know all that. Like,
Well,
how would this get
we
used?
researched,
That's
were
where
able to
we need
save the 20
like the
kilowatts
partners to
for
come on
computation.
stage and
This entire
start
rack
talking
is
about what they're going to do
120
with it, like
kilowatts,
Yeah, but
120 kilowatts.
yeah,
So-
just not those other partners they said in the
Pretty
beginning, because all
cool.
they'll tell us is
It goes
how it
in
was
at
used
45
technically
degrees
with their
C, a room
technical, with their
temperature.
hardware.
Yeah, no, we
But
want
yeah.
It's
application
45
folks.
degrees C.
Exactly.
Come on.
Out your
What's the
jacuzzi.
use cases?
The
How's this
room
going to be
temperature
used?
goes
What's
in,
the
jacuzzi
plan?
comes out 2 liters per second.
See, they don't even know when to clap. I mean, this is really
No.
funny. This is kind of amazing.
We could sell
People
a
don't know when to
peripheral.
clap. He's talking so above everybody. I think they don't know what's up.
600,000 parts.
Well, it's just it's hard to grasp
You know,
the
you guys make
implications of
GPUs.
this. That's
We
like,
do.
this is so
But
big
this is
Yeah,
what
it's
GPU
so
and
looks
big.
like
so
to me.
powerful.
When somebody says GPU,
We don't have the
I
brain
see
to
this.
understand
No.
what he's
2
saying.
years ago,
I
when I saw
literally do
GPU, it was
not.
the HGX. It was 70 pounds, 35,000 parts. Our GPUs now are 600,000 parts and 3,000 pounds. 3,000 pounds. 3,000 pounds. That's kind of like the weight of a, carbon
Car.
fiber Ferrari. I don't know if that's useful metric, but
Not.
everybody's going, I feel it. I feel it. I get it. I get that.
Yeah,
Now that
that's
you
what they're
mentioned
doing.
that, I feel it. I don't know what's 3,000 pounds. Okay, so 3,000 pounds, ton and a half.
There you go.
So it's not quite an elephant. So this is what
It's
a
not.
DGX looks like. Now let's see what it looks like in operation. Okay, let's imagine how do we
really
put this to work and
geeking
what
out
does that
here.
mean?
I mean, I
Well,
get it.
if
It's
you
a
were to
developer
train a
audience.
GPT
We're not
model,
the
1.8
audience for
trillion
this, but
parameter model,
he's like, it's harder to
it took,
grasp than
it
what
took
Larry
about,
Ellison used
apparently
to do.
about
Oh, he's
3 to
gone
5
way
months or
beyond
so,
Larry
Yeah.
Ellison.
with 25,000
At the same
amperes.
time,
If
you
we were to
are,
train with Hopper, it would
I
probably
mean,
take
I
something like
am
8,000 GPUs.
astounded at the
It would consume
magnitude of
15
it
megawatts.
all.
8,000 GPUs.
I mean,
15
that it's
megawatts.
just
Take
so
90 days, about 3 months.
utterly,
And that would allow you
it's
to
almost
train something
super,
that
it's
is,
not superhuman, forget
this
it,
groundbreaking
celestial.
AI model.
It's surreal and celestial. It's so
It's
big.
obviously not as expensive as anybody would think, but it's 8,000 GPUs. It's still a lot of money. And so 8,000 GPUs, 15 megawatts. If you were to use Blackwell to do this, it would only take 2,000 GPUs. 2,000 GPUs, same 90 days, but this is the amazing part. Only 4 megawatts of power. So from
Wow.
15, yeah, that's right.
See, that's what I was waiting to hear. That power number is crazy.
And that's our goal. Our goal is to continuously drive down the cost and the energy. They're directly proportional to each other, cost and energy associated with the computing, so that we can continue to expand and scale up the computation that we have to do to train the next generation models. Well, this is training.
Now inference.
Inference, or generation, is vitally important going forward. Probably some half of the time that NVIDIA GPUs are in the cloud these days, it's being used for token generation. They're either doing Copilot this or ChatGPT that, or all these different models that are being used when you're interacting with it, or generating images, or generating videos, generating proteins, generating chemicals. There's a bunch of generation going on. All of that is in the category of computing we call inference. But inference is extremely hard for large language models, because these large language models have several properties. One, they're very large, and so it doesn't fit on one GPU. Imagine Excel doesn't fit on one GPU, and imagine some application you're running on a daily basis doesn't fit on one computer, like a video game doesn't fit on one computer. And most, in fact, do. And many times in the past, in hyperscale computing, many applications for many people fit on the same computer. And now, all of a sudden, this one inference application where you're interacting with this chatbot, that chatbot requires a supercomputer in the back to run it. And that's the future. The future is generative with these chatbots, and these chatbots are trillions of tokens, trillions of parameters, and they have to generate tokens at interactive rates. Now, what does that mean? Oh, well, 3 tokens is about a word. Space, the final frontier. These are the adventures. That's like 80 tokens. Okay, I don't know if that's useful to you. And so, the art of communications is selecting good analogies. Yeah, this is not going well.
Dude, you freaked people out with all the numbers.
Never seen Star Trek. And so here we are. We're trying to generate these tokens. When you're interacting with it, you're hoping that the tokens come back to you as quickly as possible, and as quickly as you can read it. And so the ability for generation tokens is really important. You have to parallelize the work of this model across many, many GPUs, so that you could achieve several things. One, on the one hand, you would like throughput, because that throughput reduces the overall cost per token of generating. So your throughput dictates the cost of delivering the service. On the other hand, you have another interactive rate, which is another tokens per second, where it's about per user, and that has everything to do with quality of service. And so these two things compete against each other. And we have to find a way to distribute work across all of these different GPUs and parallelize it in a way that allows us to achieve both. And it turns out the search space is enormous. You know, I told you there's going to be math involved.
Yeah.
And everybody's going,
It's
oh,
an
dear.
understatement.
I heard some gasps just now when I put up that slide. You know, so this right here, the y-axis is tokens per second, data center throughput. The x-axis is tokens per second, interactivity of the person. And notice the upper right is the best. You want interactivity to be very high, number of tokens per second per user.
NVIDIA
You want the
Magic
tokens per
Quadrant.
second per data center to be very high. The upper right is terrific. However, it's very hard to do that. And in order for us to search for the best answer across every single one of those intersections, XY coordinates, okay, so just look at every single XY coordinate, all those blue dots came from some repartitioning of the software. Some optimizing solution has to go and figure out whether to use tensor parallel, expert parallel, pipeline parallel, or data parallel, and distribute this enormous model across all these different GPUs and sustain performance that you need. This exploration space would be impossible if not for the programmability of NVIDIA's GPUs. And so we could, because of CUDA, because we have such a rich ecosystem, we could explore this universe and find that green roofline. It turns out that green roofline, notice you got TP2, EP8, DP4. It means two tensor parallel across 2 GPUs, expert parallels across 8, data parallel across 4. Notice on the other end, you got tensor parallel across 4 and expert parallel across 16. The configuration, the distribution of that software, it's a different runtime that would produce these different results. And you have to go discover that roofline. Well, that's just one model. And this is just one configuration of a computer. Imagine all of the models being created around the world and all the different
I just want to know how this is all going to actually be used. That's where I am here.
Now that you
I'm getting a little bit of the science here and some of the technology, and I understand the power, and I understand the absolute, you know, magnitude.
This inference stuff on the Blackwell. I want to hear.
System
wow.
that's designed for trillion
I don't understand it,
parameter
but I want to hear what it is.
generative AI. The inference capability of Blackwell is off the charts. And in fact, it is some 30 times Hopper.
Damn. I don't even know what that means, but it sounds impressive.
Yeah.
For large language models like ChatGPT and others like it, the blue line is Hopper. I gave you, imagine we didn't change the architecture of Hopper, and we just made it a bigger chip. We just used the latest, greatest 10 terabytes per second. We connected the 2 chips together. We got this giant 208 billion parameter chip. How would we have performed if nothing else changed? And it turns out quite wonderfully, and that's the purple line, but not as great as it could be.
Jeez.
And that's where the FP4 Tensor Core, the new transformer engine, and very importantly, the NVLink switch. And the reason for that is because all these GPUs have to share the results, partial products. Whenever they do all gather, whenever they communicate with each other, that NVLink switch is communicating almost 10 times faster than what we could do in the past using the fastest networks. Mm-hmm. Okay, so Blackwell is going to be just an amazing system for generative AI. And in the future, data centers are going to be thought of, as I mentioned earlier, as an AI factory. An AI factory's goal in life is to generate revenues, generate, in this case, intelligence in this facility, not generating electricity as in AC generators, but of the last industrial revolution and this industrial revolution, the generation of intelligence. And so this ability is super, super important. The excitement of Blackwell is really off the charts. You know, when we first this is a year and a half ago, 2 years ago, I guess 2 years ago, when we first started to go to market with Hopper. We had the benefit of two CSPs joined us in a launch, and we were delighted. And so we had 2 customers. We have more now.
Oh, nobody gets.
Oh
it.
my God! Come on. Okay, that's what it is. All right, they saw that. Okay. Like, man, these people are really slow
Unbelievable
here.
excitement for Blackwell. Unbelievable excitement. And there's a whole bunch of different configurations. Of course, I showed you the configurations that slide into the Hopper
I don't see
form factor,
Microsoft
so
up
that's
there, though.
easy to upgrade. I showed you examples that are liquid cooled.
This might be. They were up there, but this might be a different group.
This is for the
Oh, there's
Blackwell.
Azure on the top. Azure and Oracle Cloud on the very top.
AWS, Google. Okay, all right.
Ramping to the world's AI companies, of which there are so many now, doing amazing work in different modalities. The CSPs, every CSP is geared up. All the OEMs and ODMs, regional clouds, sovereign AIs, and telcos all over the world are signing up to launch with Blackwell.
I think it's going to take a while for this
Blackwell-
stuff to sink
Blackwell
in
will
for
be
even
the-
that audience.
the
What he's
most
talking about.
successful product launch in our history, and so I can't wait to see that. I want to thank some partners that are joining us in this. AWS is gearing up for Blackwell. They're going to build the first GPU.
So
with
AWS
secure
got top
AI.
billing.
They're,
They
building
must
out
have
a
paid some money.
222
Might be out. It could be
plus
alphabetical.
system. Just now
Could
when
be.
we animated.
Could
Just
be.
now,
You're right.
the digital
Azure,
twin, if you saw
AWS.
all of those.
No, but
clusters coming
Microsoft
down.
Azure.
By the
So
way,
Yeah.
that is not just art.
Google
That
should
is
be
the
next if
digital
it's
twin of what
alphabetical.
we're building. That's how big it's going to be. Besides infrastructure, we're doing a lot of things together with AWS. We're CUDA accelerating SageMaker AI. We're
Should be
CUDA accelerating Bedrock AI.
Amazon, Google,
Amazon Robotics is working
Microsoft,
with
Oracle.
us,
That order.
using
Yeah, the big
NVIDIA
guys.
Omniverse
If it's
and
alphabetical.
SIM. AWS Health has NVIDIA
Or
Health
if it's market
integrated
leader, it's
into us. So
AWS, Azure,
AWS
and
has
Google,
has
and then
really
Oracle.
leaned into
Right.
accelerated
see.
computing. Google is gearing up for Blackwell. GCP already
Yeah,
has
that's what it is.
A100s,
It's
A100s,
alphabetical.
T4s, L4s, a whole
This is
fleet
Google.
of
Yeah,
NVIDIA CUDA
Alphabet.
GPUs.
So,
And they recently announced
well,
that
Alphabet is
Gemma
before
model that runs
Amazon.
across all of it. We're working
No,
to
it's just
optimize,
it's company name.
and accelerate
Yeah,
every aspect
Alphabet.
of GCP.
No, well, they're
Data
still calling it
process-
Google
Data
though.
processing, their data processing engines.
You saw
chat,
that they're using the Google
XLA,
logo.
Vertex AI, and Mujoko for robotics. So we're working with Google and GCP across a whole bunch of initiatives. Oracle is gearing up.
Okay,
for
no,
yeah.
Oracle.
not
Oracle
no.
is a great partner of ours
Random.
for NVIDIA DGX Cloud, and we're also working together to accelerate something that's really important to a lot of companies, Oracle database. Microsoft is accelerating.
Okay, look at how big this-
Microsoft is gearing up for Blackwell.
All right.
Microsoft and NVIDIA has a wide-ranging partnership.
Remember they did
We're
that AI
accelerating-
chip
accelerating all kinds
computer,
of
the biggest
services when you chat,
AI
obviously,
computer or
and,
something like that?
AI
Yep.
services that are in Microsoft Azure. It's very, very likely NVIDIA's in the back doing the inference and the token generation. They built the largest NVIDIA.
I say thank you. You're welcome with a question mark at the end of the you're welcome.
Don't thank us.
Point of
Thank
ours.
Jensen.
Yeah, you're welcome.
The NVIDIA ecosystem to
So
Azure.
what? No.
NVIDIA DGX Cloud to Azure. NVIDIA Omniverse is now hosted in Azure. NVIDIA Healthcare is in Azure.
As you notice,
Oh,
he spent a
yeah.
lot more
Deeply
time on
integrated
Azure
and
here.
Deeply connected with Microsoft Fabric. The whole industry is gearing up for
All right, those are the
Blackwell.
big four.
This is what I'm about to show you. Most of the scenes that you've seen so far of Blackwell are the full fidelity design of Blackwell. Everything in our company has a digital twin, and in fact, this digital twin idea is really spreading, and it helps companies build very complicated things perfectly the first time. And what could be more exciting than
Perfectly the first time.
creating a digital twin to build a computer that was built in a digital twin? And so let me show you what Wistron's doing.
This is getting a little over the top.
To meet the demand for NVIDIA accelerated computing, Wistron, one of our leading manufacturing partners, is building digital twins of NVIDIA DGX and HGX factories using custom software developed with Omniverse SDKs and APIs. For their newest factory, Wistron started with a digital twin to virtually integrate their multi-CAD and process simulation data into a unified view. Testing and optimizing layouts in this physically accurate digital environment increased worker efficiency by 51%. During construction, the Omniverse digital twin was used to verify that the physical build matched the digital plans. Identifying any discrepancies early has helped avoid costly change orders. And the results have been impressive. Using a digital twin helped bring Wistron's factory online in half the time.
Notice Apple
just
wasn't
2.5
mentioned at all
months
on this
instead of
thing so
5.
far.
In operation, the Omniverse
Except
digital
right
twin
there.
helps
Yes, I
Wistron
saw the
rapidly
Vision
test
Pro.
new
That was the
layouts
only
to
thing.
accommodate
Yeah.
new processes or improve operations in the existing space, and monitor real-time operations using live IoT data from every machine on the production line, which ultimately enabled Wistron to reduce end-to-end cycle times by 50% and defect rates by 40%. With NVIDIA AI and Omniverse, NVIDIA's global ecosystem of partners are building a new era of accelerated AI-enabled digitalization.
That's how we.
That
That's
place
the
is
way it's
standing
going to be in
room
the
only.
future. We're going to manufacturing everything digitally first, and then we'll
I
manufacture.
wonder what the audience is.
People ask me, how did it
I
start?
don't think that convention center
What
is
got you guys
huge.
so excited?
It's pretty big, but not huge.
What was it that you saw that caused you
Hey, Paul
to
Sweeney.
put it all in on this incredible idea? And it's this. Hang on a second.
Oh, he's a cat person there, Paul. Look at that.
Guys, that was going to be such a moment.
What are
worry.
what are we waiting for?
I have
That's what
no
happens
idea
when
what.
we don't rehearse.
What happened?
I have no idea. Something happened.
This, as you know, was First Contact. 2012, AlexNet. You put a cat into this computer, and it comes out and it says,
Literally?
cat. And we said, oh my God, this is going to change everything. You
Yeah.
take 1 million numbers, across 3 channels, RGB. These numbers make no
Color.
sense to anybody.
Color.
You put it into this software, and
Thanks, young.
compress it,
Thanks, sir.
It reduces it from 1 million dimensions. It turns it into 3 letters, 1 vector, 1 number. And it's generalized. You could have the cat be different cats. And you could have it be the front of the cat and the back of the cat. And you look at this thing, you say, unbelievable. You mean any cats? Yeah, any cat. And it was able to recognize all these cats. And we realized how it did it. Systematically,
Hey, if
structurally.
anybody is
scalable.
interested out in the audience, interested in coming
How
on
big
to
do you
talk
make
more
it?
about this,
Well,
since
how big do you want
clearly
it?
this is not exactly our
As
wheelhouse,
we imagined,
let us know in the
this is a
comments and we'll
completely
send you the
new way of
stream.
writing
Well,
software.
I don't know. I
Yeah.
don't know how long
Today,
this
as
is
you
going to
know,
be.
I'm guessing
you
another
have-
20 minutes.
You type in the
Might-
word CAT, and what comes out is a cat.
Right.
It went the other way. Am I right?
Yeah.
Unbelievable.
It actually is.
How
What
is it
there,
possible?
this I get.
That's right. How is it possible you took 3 letters and you generated 1 million pixels from it, and it made sense?
Absolutely
Well,
right.
that's a miracle. And here we are, just literally 10 years.
I remember wondering when we were going to get to an age where we could search a video for
We recognize
um,
videos and sound,
specific
images. Not only do we
images
recognize them,
that we could
understand
identify
their
by
meaning.
text, using
We
text.
understand the meaning of the text. That's the reason why it can chat with you. It can summarize for you. It understands the text.
Man, he looks so
It
small.
understood, not just recognizes the English, it understood the English. It doesn't just recognize the
Screen.
pixels, it understood the pixels. And you can even condition it between 2 modalities. You can have language, condition, image, and generate all kinds of interesting things.
That's got to be a
if you can
huge screen
understand
behind
these
him.
things, what
Yeah.
else can you understand that you've
The bottom of
digitized?
the screen, it said amino acid
The reason why
protein.
we
I'm
started
wondering
with
what
text
that was
and,
all about.
images is because we digitized those. But
He's
what else have
mentioning
we
that
digitized?
that can be
Turns out we
generated too.
digitized a lot of things, proteins and genes
Here we
and
go.
brain waves. Anything you can
Brain
digitize, so
waves.
long as there's structure,
Brain
we can
waves.
probably
Yeah,
learn
no,
some
I get
patterns
it.
from it. And if we can learn the patterns from it, we
They're
can
actually
understand
doing
its
that
meaning.
now. I was reading
We
an
can
article on
understand
that
its
in
meaning.
Wired just
We
recently.
might be able to generate it as well. And so therefore, the generative AI revolution is here. Well, what else can we
Thoughts
generate? What else can we
generate
learn?
activity,
Well, one
physical
of the things
activity.
we would love to learn is we would love to learn climate. We would love to learn extreme weather. We would love to learn how we can
Thanks, Paul.
predict
Understood.
future weather at regional scales at sufficiently high resolution such that we can keep people out of harm's way before harm comes. Extreme weather cost the world $150 billion. Surely more than that, it's not evenly distributed. $150 billion is concentrated in some parts of the world, and of course, to some people of the world. We need to adapt, and we need to know what's coming. And so we're creating Earth 2, a digital twin of the Earth for predicting weather, and we've made an extraordinary invention called CorDiff.
Well, it's
The ability to use generative
anticipating
AI to predict
the activity of
weather
complex and
extremely
chaotic
high resolution.
systems.
Let's take a look.
That's what he's talking about.
As the Earth's climate changes, AI-powered weather forecasting is allowing us to more accurately predict and track severe storms, like Super Typhoon Chanthu, which caused widespread damage in Taiwan and the surrounding region in 2021. Current AI forecast models can accurately predict the track of storms, but they are limited to 25-kilometer resolution, which can miss important details. Nvidia's CorDiff is a revolutionary new generative AI model trained on high-resolution, radar-assimilated WRF weather forecasts and ERA 5 reanalysis data. Using CorDiff, extreme events like Chanthu can be super-resolved from 25-kilometer to 2-kilometer resolution, with 1,000 times the speed and 3,000 times the energy efficiency of conventional weather models. By combining the speed and accuracy of NVIDIA's weather forecasting model ForecastNet and generative AI models like CorDiff, we can explore hundreds or even thousands of kilometer-scale regional weather forecasts to provide a clear picture of the best, worst, and most likely impacts of a storm. This wealth of information can help minimize loss of life and property damage. Today, CorDiff is optimized for Taiwan, but soon, generative supersampling will be available as part of the NVIDIA Earth 2 inference service for many regions across the globe.
Yeah, I think Yoon has a comment about Watson. I think to his
The
point,
weather company
I
is the
remember
trusted
too,
source of
but
global weather prediction.
the difference here is the
Working together
depth
to
of
accelerate the
detail
weather simulation.
of the
First
forecasted
principles
global weather
based
predictions,
simulation. However,
not just
they're
the
also
fact
going
that
to
they can
integrate Earth
anticipate.
2 CorDiff
The
so
depth
that they
of
can help
detail.
businesses and countries do
That I
regional,
think in the amount of data and the ability to
high-resolution
compute
weather
it and
prediction.
learn from it
So if you have some weather prediction you'd like to know,
10 years
you'd
ago
like
was
to
nothing
do,
compared to what
reach
he's
out to
talking about
the weather
now.
company. Really exciting work. NVIDIA Healthcare. Something we started 15 years
Okay,
ago.
here we
We're
go.
super excited about this. This is an area where we're very, very proud. Whether it's medical imaging or gene sequencing or computational chemistry, it is very likely that NVIDIA is the computation behind it. We've done so much work in this area. Today, we're announcing that we're going to do something really, really cool. Imagine all of these AI models that are being used to generate images and audio, but instead of images and audio, because it understood images and audio, all the digitization that we've done for genes and proteins and amino acids, that digitization capability is now passed through machine learning so that we understand the language of life. The ability to understand the language of life, of course, we saw the first evidence of it with AlphaFold. This is really quite an extraordinary thing. After decades of painstaking work, the world had only digitized and reconstructed using cryo-electron microscopy or crystal X-ray crystallography. These different techniques painstakingly reconstructed the protein, 200,000 of them, in just what is it, less than a year or so, AlphaFold has reconstructed 200 million proteins, basically every protein, every living thing that's ever been sequenced. This is completely revolutionary. Well, those models are incredibly hard to use, incredibly hard for people to build. And so what we're going to do is we're going to build them. We're going to build them for the researchers around the world. And it won't be the only one. There'll be many other models that we create. And so let me show you what we're going to do with it.
Virtual screening for new medicines is a computationally intractable problem. Existing techniques can only scan billions of compounds and require days on thousands of standard compute nodes to identify new drug candidates. Nvidia BioNeMo NIMs enable a new generative screening paradigm. Using NIMs for protein structure prediction with AlphaFold, molecule generation with MolMIM, and docking with DiffDock, we can now generate and screen candidate molecules in a matter of minutes. MolMIM can connect to custom applications to steer the generative process, iteratively optimizing for desired properties. These applications can be defined with BioNeMo microservices or built from scratch. Here, a physics-based simulation optimizes for a molecule's ability to bind to a target protein, while optimizing for other favorable molecular properties in parallel. MolMIM generates high-quality drug-like molecules that bind to the target and are synthesizable, translating to a higher probability of developing successful medicines faster. BioNeMo is enabling a new paradigm in drug discovery with NIMs, providing on-demand microservices that can be combined to build powerful drug discovery workflows like de novo protein design or guided molecule generation for virtual screening. BioNeMo NIMs are helping researchers and developers reinvent computational drug design.
NVIDIA MolMIM, Core Diff, there's a whole bunch of other models, computer vision models, robotics models, and even, of course, some really, really terrific open source language models. These models are groundbreaking. However, it's hard for companies to use. How would you use it? How would you bring it into your company and integrate it into your workflow? How would you package it up and run it? Remember, earlier I just said that inference is an extraordinary computation problem. How would you do the optimization for each and every one of these models and put together the computing stack necessary to run that supercomputer so that you can run these models in your company? And so we have a great idea. We're going to invent a new way for you to receive and operate software. This software comes basically in a digital box. We call it a container. And we call it the NVIDIA Inference Microservice, a NIM. And I'll explain to you what it is. A NIM, it's a pre-trained model, so it's pretty clever. And it is packaged and optimized to run across NVIDIA's installed base, which is very, very large. What's inside it is incredible. You have all these pre-trained, state-of-the-art open source models. They could be open source. They could be from one of our partners. It could be created by us, like NVIDIA MolMIM. It is packaged up with all of its dependencies. So CUDA, the right version. cuDNN, the right version. TensorRT, LLM, distributing across the multiple GPUs. Triton Inference Server, all completely packaged together. It's optimized depending on whether you have a single GPU, multi-GPU, or multi-node of GPUs. It's optimized for that. And it's connected up with APIs that are simple to use. Now think about what an AI API is. An AI API is an interface that you just talk to. And so this is a piece of software in the future that has a really simple API, and that API is called human. And these packages, incredible bodies of software, will be optimized and packaged, and we'll put it on a website. And you can download it. You could take it with you. You could run it in any cloud. You could run it in your own data center. You can run in workstations if it fit. And all you have to do is come to ai.nvidia.com. We call it NVIDIA Inference Microservice, but inside the company, we all call it NIMS.
NIMS.
Okay? Just imagine, someday there's going to be one of these chatbots, and these chatbots is going to just be in a NIM, and you'll assemble a whole bunch of chatbots, and that's the way software is going to be built someday. How do we build software in the future? It is unlikely that you'll write it from scratch or write a whole bunch of Python code or anything like that. It is very likely that you assemble a team of AIs. There's probably going to be a super AI that you use that takes the mission that you give it and breaks it down into an execution plan. Some of that execution plan could be handed off to another NIM. That NIM would maybe understand SAP. The language of SAP is ABAP. It might understand ServiceNow, and it go retrieve some information from their platforms. It might then hand that result to another NIM who goes off and does some calculation on it. Maybe it's an optimization software, a combinatorial optimization algorithm. Maybe it's some basic calculator. Maybe it's pandas to do some numerical analysis on it. And then it comes back with its answer, and it gets combined with everybody else's, and because it's been presented with, this is what the right answer should look like, it knows what right answers to produce, and it presents it to you. We can get a report every single day at top of the hour that has something to do with a build plan or some forecast or some customer alert or some bugs database or whatever it happens to be, and we could assemble it using all these NIMs. And because these NIMs have been packaged up and ready to work on your systems, so long as you have NVIDIA GPUs in your data center or in the cloud, this NIMs will work together as a team and do amazing things. And so we decided, this is such a great idea, we're going to go do that. And so NVIDIA has NIMs running all over the company. We have chatbots being created all over the place, and one of the most important chatbots, of course, is a chip designer chatbot. You might not be surprised, we care a lot about building chips. And so we want to build chatbots, AI co-pilots that are co-designers with our engineers. And so this is the way we did it. So we got ourselves a Llama 2. This is a 70B, and it's packaged up in a NIM. And we asked it, what is a CTL? Well, it turns out CTL is an internal program, and it has an internal proprietary language. But it thought the CTL was a combinatorial timing logic, and so it describes, conventional knowledge of CTL. But that's not very useful to us. And so we gave it a whole bunch of new examples. This is no different than onboarding an employee. We say, thanks for that answer. It's completely wrong. And then we present to them, this is what a CTL is. Okay, and so this is what a CTL is at NVIDIA. And the CTL, CTL stands for Compute Trace Library, which makes sense. We're tracing compute cycles all the time, and it wrote the program. Isn't that amazing?
I think most of us are overwhelmed at this point.
Yeah.
Trying to let this stuff sink in.
This is what you can do with a NIM. First thing you can do with this, customize it.
I'm going to need an NV link to let this sink in.
That helps you curate the data, preparing the data so that you can.
And I throw in a couple of NIMs while I read it.
Fine-tune them.
No, I'm pretty dim already. Thanks.
Guardrail it. You can even evaluate the answer.
This is
its performance against.
This is a discussion
that's called
with an audience of
microservice
theoretical enterprise architects, or to, I think it was Paul Sweeney's comment. What did he say? The promise of soap delivered today. Remember service-oriented architecture, right? Back in the day.
Yeah.
And what was going to replace it again? REST. REST was going to destroy soap.
Second is to help you modify it.
As it turned out, REST is all you need to get over being sick.
You could deploy it.
A good night's rest.
Infrastructure called DGX
That's
Cloud.
exactly right.
Deploy it on-prem. You could deploy it anywhere you like.
But this thing, he's been at this for almost an hour and a half. And there's no way, even folks that are in the audience can't keep up and let all that stuff that he just talked about sink in, let alone mere mortals like us.
Well, I think also it's not a problem because his audience is his audience, different audience.
No, it's not a problem.
Right, but no, I'm just saying, but the only thing that I understand I
The
can
other thing that you
understand
could-
these
you
things
should
at a
need
very
to
high
do
level,
is
and
to
but
understand your
he's
proprietary information.
down in the weeds to a
Remember,
point where I
inside our
just
company,
don't.
the vast majority of our data is not
Well, I
outside.
mean, I guess it's just
Inside
because
our
it doesn't
company. It's been sitting there,
mean much
you
to
know,
my daily life
being used all the time,
directly.
and
So
it's
now the
basically NVIDIA's
implications
intelligence.
of it are
We would like
massive
to take that
and
data,
probably mean a lot to my daily life, which is
learn
something
its
I would
meaning, like we learned
been
the
very
meaning of almost
interested to
anything else
hear,
that
but I
we
heard
talk about.
only a little of
Learn
that.
its meaning, and
Well,
then
the scale and the
re-index
scope
that
of what he's talking
knowledge
about
into a new
Yeah,
type of
is
database,
it's
called a
hard
vector
for
database.
most of us to
So
understand.
you're
I
essentially
But
agree.
and
structured
even
data
the
or
folks in that
unstructured
audience
data,
who
you
do this
learn
stuff
its
for a
meaning,
living, you
you
can tell
encode its meaning
they're
so that
trying
it
to
becomes
kind
an
of make
AI
it all sink
database,
in
and
and
that AI
understand it. If they're
database
trying to do that,
in the future, once
you
you
know,
create it, you can
I'm not
talk to
trying
it.
to do it tonight.
And so let me give you an
But it's
example of what you
interesting
do.
as hell.
So suppose you've got a whole bunch of multi-modality data, and one good example of
Well,
that is PDF. So you take the PDF, you take all of your PDFs, all your favorite, the stuff that is proprietary to you, critical to your company. You can encode it just as we encode.
I mean, what we can do is wrap at 5:30.
Word cat. We can encode all of your PDF, and it
Bring
turns
on.
into
We'll see what
vectors that are now stored inside your vector
I
database.
think it
So
was supposed to
becomes
go
the
4 to
proprietary
6,
information
but
of your company.
it feels like there's a
Once you have
wrap up
that
coming
proprietary
here.
information,
Yeah.
you can chat to it.
But one of the things
It's
that's
a smart
amazing to me is
database. So you
he
just
didn't
chat
bring on
with the data.
anybody else. It was
And
just
how
him
much more enjoyable
talking
is that?
through all this stuff.
For our software team,
It's amazing what
chat
this,
with the bugs database.
not only what they've done, but
How many bugs was
you
there
think
last
about
month?
it, he's
Are
the
we
guy that
making any
started all
progress?
this, and
And then
he has
after
such a
you're done talking to
grasp on
this,
what's going on. It's pretty
you know,
amazing.
bugs database, you
I
use
know.
Verity.
Well, he's
So
I mean, he is a
another
completely
chatbot.
remarkable human being.
He's a
Period.
physicist and
Period.
CEO,
You can do it.
entrepreneur. It's pretty
Yeah.
amazing.
He's also normally a great speaker too.
What? But he's so effortless the way he's
Okay, so
Right.
we
coming up.
call this Nemo Retriever.
He's also
and the reason for that is
comfortable when
because
his
ultimately
jokes
his
don't
job
fly.
is to go
Right.
retrieve information as quickly as
His
possible.
comfort zone
You
is
just talk
pretty
to him.
heavy. It's
Hey,
pretty
show
high.
me this information. It goes, it brings it back to you. Is it, do you mean this? You go, yeah, perfect. Okay. And so we call it the Nemo Retriever. Well, the Nemo service helps you create all these things, and we have all these different NIMs. We even have NIMs of digital humans.
I'm Rachel, your AI care manager.
Okay, so it's a really short clip, but there were so many videos to show you. I guess so many other demos to show you, and so I had to cut this one short. But this is Diana. She is a digital human NIM, and you just talked to her, and she's connected in this case to Hippocratic AI's large language model for healthcare, and it's truly amazing. She is just super smart about healthcare things. And so after you're done, after my Dwight, my VP of software engineering, talks to the chatbot for bugs database, then you come over here and talk to Diane. And so Diane is completely animated with AI, and she's a digital human.
He's
There's
improvising
so many
now.
companies that
Something
would
didn't
like
work,
to build.
Yeah.
They're sitting on gold mines. The enterprise IT industry is sitting on a gold mine. It's a gold mine because they have so much understanding of the way work is done. They have all these amazing tools that have been created over the years, and they're sitting on a lot of data. If they could take that gold mine and turn them into co-pilots, these co-pilots could help us do things. And so just about every IT franchise, IT platform in the world that has valuable tools that people use is sitting on a gold mine for co-pilots. And they would like to build their own co-pilots and their own chatbots. And so we're announcing that NVIDIA AI Foundry is working with some of the world's great companies. SAP generates
Here we go.
87%
This is what we're
of the
waiting for.
world's global commerce. Basically, the world runs on SAP. We run on
Co-pilots
SAP.
here.
NVIDIA and SAP are building SAP Joule co-pilots using NVIDIA Nemo and DGX Cloud. ServiceNow, they run 85% of the world's Fortune 500 companies run their people and customer service operations on ServiceNow. And they're using NVIDIA AI Foundry to build ServiceNow Assist virtual assistants. Cohesity backs up the world's data. They're sitting on a gold mine of data. Hundreds of exabytes of data, over 10,000.
Yeah, they're
NVIDIA AI Foundry is working with them, helping them build their Gaia generative AI agent.
Jeez.
Snowflake is a company that stores the world's
Makes sense
digital
here.
warehouse in the cloud and serves over 3 billion queries a day for 10,000 enterprise customers. Snowflake is working with NVIDIA AI Foundry to build copilots with NVIDIA NeMo and NIMS. NetApp, nearly half of the files in the world are stored on-prem on NetApp.
Wow.
NVIDIA AI Foundry is helping them build chatbots and copilots like those vector databases and retrievers with NVIDIA NeMo and NIMS. And we have a great partnership with Dell. Everybody who is building these chatbots and generative AI, when you're ready to run it, you're going to need an AI factory. And nobody is better at building end-to-end systems of very large scale for the enterprise than Dell. And so anybody, any company, every company will need to build AI factories. And it turns out that Michael is here. He's happy to take your order.
Oh, there he is.
Ladies and gentlemen, Michael Dell.
Just think, though, usually a guy like that, he's only there because he's a part of the
let's
keynote.
talk about the next wave of robotics.
Nobody has
The
been a
next
part of
wave
this
AI,
keynote but
robotics.
this guy. This is
Physical
amazing.
AI. So far, all of the AI that we've talked about is one computer. Data comes into one computer, lots of the world's, if you will, experience in digital text form. The AI imitates us by reading a lot of the language to predict the next words. It's imitating you by studying all of the patterns and all the other previous examples. Of course, it has to understand context and so on and so forth, but once it understands the context, it's essentially imitating you. We take all of the data, we put it into a system like DGX, we compress it into a large language model, trillions and trillions of parameters become billions and billions, trillions of tokens becomes billions of parameters, these billions of parameters becomes your AI. Well, in order for us to go to the next wave of AI, where the AI understands the physical world, we're going to need 3 computers. The first computer is still the same computer. It's that AI computer that now it's going to be watching video, and maybe it's doing synthetic data generation, and maybe there's a lot of human examples. Just as we have human examples in text form, we're going to have human examples in articulation form, and the AIs will watch us, understand what is happening, and try to adapt it for themselves into the context. And because it can generalize with these foundation models, maybe these robots can also perform in the physical world fairly generally. So I just described in very simple terms, essentially what just happened in large language models, except the GPT moment for robotics may be right around the corner. And so we've been building the end-to-end systems for robotics for some time. I'm super, super proud of the work. We have the AI system, DGX. We have the lower system, which is called AGX for autonomous systems, the world's first robotics processor. When we first built this thing, people are, what are you guys building? It's a SoC, it's one chip, it's designed to be very low power, but it's designed for high-speed sensor processing and AI. And so if you want to run transformers in a car, or you want to run transformers in a anything that moves, we have the perfect computer for you. It's called the Jetson. And so the DGX on top for training the AI, the Jetson is the autonomous processor, and in the middle, we need another computer. Whereas large language models have the benefit of you providing your examples and then doing reinforcement learning human feedback. What is the reinforcement learning human feedback of a robot? Well, it's reinforcement learning physical feedback. That's how you align the robot. That's how the robot knows that as it's learning these articulation capabilities and manipulation capabilities, it's going to adapt properly into the laws of physics. And so we need a simulation engine that represents the world digitally for the robot, so that the robot has a gym to go learn how to be a robot. We call that virtual world Omniverse. And the computer that runs Omniverse is called OVX. And OVX, the computer itself, is hosted in the Azure cloud. Okay? And so basically we built these 3 things, these 3 systems. On top of it, we have algorithms for every single one. Now, I'm going to show you one super example of how AI and Omniverse are going to work together. The example I'm going to show you is kind of insane, but it's going to be very, very close to tomorrow. It's a robotics building. This robotics building is called a warehouse. Inside the robotics building are going to be some autonomous systems. Some of the autonomous systems are going to be called humans, and some of the autonomous systems are going to be called forklifts. And these autonomous systems are going to interact with each other, of course, autonomously, and it's going to be overlooked upon by this warehouse to keep everybody out of harm's way. The warehouse is essentially an air traffic controller. And whenever it sees
Jesus.
something happening, it will redirect traffic and give new waypoints, just new waypoints to the robots and the people, and they'll know exactly what to do. This warehouse, this building, you can also talk to. Of course you could talk to it. Hey, SAP Center, how are you feeling today? For example. And so you could ask the warehouse the same questions. Basically, the system I just described will have Omniverse Cloud that's hosting the virtual simulation, and AI running on DGX Cloud, and all of this is running in real time. Let's take a look.
The future of heavy industries starts as a digital twin. The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in sophisticated digital twins. This Omniverse digital twin of a 100,000 square foot warehouse is operating as a simulation environment that integrates digital workers, AMRs running the Nvidia Isaac Perceptor stack, centralized activity maps of the entire warehouse from 100 simulated ceiling mount cameras using Nvidia Metropolis, and AMR route planning with Nvidia cuOpt. Software in loop testing of AI agents in this physically accurate simulated environment enables us to evaluate and refine how the system adapts to real-world unpredictability. Here, an incident occurs along this AMR's planned route, blocking its path as it moves to pick up a pallet. Nvidia Metropolis updates and sends a real-time occupancy map to cuOpt, where a new optimal route is calculated. The AMR is enabled to see around corners and improve its mission efficiency. With generative AI-powered Metropolis Vision Foundation models, operators can even ask questions using natural language. The visual model understands nuanced activity and can offer immediate insights to improve operations. All of the sensor data is created in simulation and passed to the real-time AI, running as NVIDIA Inference Microservices, or NIMs. And when the AI is ready to be deployed in the physical twin, the real warehouse, we connect Metropolis and Isaac NIMs to real sensors with the ability for continuous improvement of both the digital twin and the AI models.
Isn't that incredible? And so,
Wow.
remember,
There's a lot going on here,
a
man.
future facility,
That I got.
warehouse, factory.
I got it, but there's a
building
lot going
will be
on there.
software defined. And so the software is running. How else would you test the software? So you test.
I remember a much more primitive version of something semi-similar that Johnson & Johnson did with Coveo.
Running their own autonomous robotic stack. And so the way you integrate software in the future,
where
ICD in the future for robotic systems is with digital twins.
it could identify in a production process of 3,000 plus points. If something went wrong in a production process, it could immediately identify which points in the process were problematic, what the problem was, and it could just, but then it wasn't automated from there on, right? From then on, it became a manual process. But the identification of the problem is something that existed at a smaller level for a long time.
AI, and integrated it with the ability to chat USD. The language of our language is, human, and Omniverse's language, as it turns out, is universal scene description. And so that language is rather complex, and so we've taught our Omniverse that language. And so you can speak to it in English, and it would directly generate USD. And it would talk back in USD, but converse back to you in English. You could also look for information in this world semantically. Instead of the world being encoded semantically in language, now it's encoded semantically in scenes. And so you could ask it of certain objects or certain conditions and certain scenarios, and it can go and find that scenario for you. It also can collaborate with you in generation. You could design some things in 3D, it could simulate some things in 3D, or you could use AI to generate something in 3D. Let's take a look at how this is all going to work. We have a great partnership with Siemens Siemens is the world's largest industrial engineering and operations platform.
Their
We've
partners
seen now so many different
and
companies
what they're
in
working
the
on
industrial
are kind of
space. Heavy
unparalleled.
industries is one of the greatest final frontiers of IT.
Advantage of
And we finally now have
enterprise scale
necessary
hardware.
technology to go and
Software
make
enterprise
real impact.
software
Siemens
companies.
is building the industrial
data.
metaverse.
Right.
Today we're announcing that Siemens is connecting their crown jewel accelerator to Nvidia Omniverse. Let's take a look.
Siemens technologies transform the everyday for everyone. Teamcenter X, our leading product lifecycle management software from the Siemens Accelerator platform, is used every day by our customers to develop and deliver products at scale. Now we are bringing the real and the digital worlds even closer by integrating Nvidia AI and Omniverse technologies into Teamcenter X. Omniverse APIs enable data interoperability and physics-based rendering to industrial scale design and manufacturing projects. Our customers, HD Hyundai, market leader in sustainable ship manufacturing, builds ammonia and hydrogen-powered ships, often comprising over 7 million discrete parts. With Omniverse APIs, Teamcenter X lets companies like HD Hyundai unify and visualize these massive engineering data sets interactively and integrate generative AI to generate 3D objects or HDRI backgrounds to see their projects in context. The result, an ultra-intuitive photoreal, physics-based digital twin that eliminates waste and errors,
Wow.
delivering huge savings in cost and time. And we are building this for collaboration, whether across more Siemens accelerator tools like Siemens NX or Star CCM+, or across teams working on their favorite devices in the same scene together. And this is just the beginning. Working with Nvidia, we will bring accelerated computing, generative AI, and Omniverse integration across the Siemens accelerator portfolio.
See, this is the difference between what Zuck was talking about with that metaverse and somebody who actually has a real world use case for this stuff.
Good friend of mine, Roland Bush,
not just trying to make stuff up out of nothing.
Siemens. Once you get Omniverse connected into your workflow, your ecosystem, from the beginning of your design to engineering to manufacturing planning, all the way to digital twin operations, once you connect everything together, it's insane how much productivity you can get. And it's just really, really wonderful. All of a sudden, everybody's operating on the same ground truth. You don't have to exchange data and convert data, make mistakes. Everybody is working on the same ground truth. From the design department to the art department, the architecture department, all the way to the engineering and even the marketing department. Let's take a look at how Nissan has integrated Omniverse into their workflow. And it's all because it's connected by all these wonderful tools and these developers that we're working with. Take a look.
That's right, Alan.
I wonder how long it took them to put this together, because this presentation has really been, with a few technical glitches, spot on. I mean, nothing wrong.
我喜欢有质感些的灰色。
非常好的选择。
Look at this.
Jesus. Very fast generative AI.
But it's so different than what we see. With we can spot generated pictures at this point. They all kind of look the same.
Yeah.
Not like this stuff here.
Well, these are realistic.
Yeah.
As opposed to cartoony.
Yeah.
Or illustrative. You know, it's fascinating to me, even though it's only implied and has been sort of implied a little bit here, but it's also the biggest possible business use cases for virtual
That was not
virtual.
an animation. That was
I mean,
Omniverse.
for what do you call it?
Today we're announcing that Omniverse
The
Cloud
Vision Pro.
streams to the Vision Pro.
Ah,
And
All right, there you go.
speak of the devil. So I guess it's not so implied anymore.
So this is going to help Apple
it
out
is
as much as it's going
very,
to help
very
Nvidia.
strange that you walk around virtual doors when I was getting out of that car, and everybody does it. It is really, really quite amazing. Vision Pro connected to Omniverse portals you into Omniverse. And because all of these CAD tools and all these different design tools are now integrated and connected to Omniverse, you can have this type of workflow. Really
It's not an Apple
Let's talk
partner.
about
No, it's
robotics.
not like an Apple partnership.
Everything that
he's
moves
talking
will
about.
be robotic. There's no
Just
question about that.
Apple
It's
developer
safer,
tool
it's more
in the Vision
convenient.
Pro.
And one of the largest industries is going to be automotive.
That was
We
funny.
build the
That
robotic
was funny
stack from
coincidence.
top to bottom, as I was mentioned. From the computer system, but in the case of self-driving cars, including the self-driving car application. At the end of this year, or I guess beginning of next year, we will be shipping in Mercedes, and then shortly after that, JLR. And so these autonomous robotic systems are software defined. They take a lot of work to do, has computer vision, has obviously artificial intelligence, control and planning, all kinds of very complicated technology, and takes years to refine. We're building the entire stack. However, we open up our entire stack for all of the automotive industry. This is just the way we work. The way we work in every single industry, we try to build as much of it as we can so that we understand it, but then we open it up so everybody can access it. Whether you would like to buy just our computer, which is the world's only full, functional, safe ASIL-D system that can run AI, this functional, safe ASIL-D quality computer, or the operating system on top, or, of course, our data centers, which is in basically every AV company in the world. However you would like to enjoy it, we're delighted by it. Today, we're announcing that BYD, the world's largest EV company, is adopting our next generation. It's called Thor. Thor is designed for transformer engines. Thor, our next generation AV computer, will be used by BYD.
Yay.
Yay.
You probably don't know this fact that we have over 1 million robotics developers.
Yeah, I would thank you
created
for telling us
Jetson,
now.
which
That
is
would have been on
robotics
Stump the
computer.
Godfather
We're
if I
so
wasn't
proud of that. The
watching.
amount of
Yeah, that
software
would have
goes
been a
on
good
top
one.
of it is insane. But the reason why we can do it at all is because it's 100% CUDA compatible. Everything that we do in our company is in service of our developers. And by us being able to maintain this rich ecosystem and make it compatible with everything that you
Really talk
access
about
from us,
developer
we can
partners
bring all of
much.
that incredible capability to this little tiny computer we call Jetson, a robotics computer. We also today are announcing this incredibly advanced new SDK. We call it Isaac Perceptor. Isaac Perceptor, most of the robots today are pre-programmed. They're either following rails on the ground, digital rails, or they'd be following April tags. But in the future, they're going to have perception. And the reason why you want that is so that you could easily program it. You say, I would like to go from point A to point B, and it will figure out a way to navigate its way there. So by only programming waypoints, the entire route could be adaptive. The entire environment could be reprogrammed, just as I showed you at the very beginning with the warehouse. You can't do that with pre-programmed AGVs. If those boxes fall down, they just all gum up and they just wait there for somebody to come clear it. And so now, with the Isaac Perceptor, we have incredible state-of-the-art vision odometry, 3D reconstruction, and in addition to 3D reconstruction, depth perception. The reason for that is so that you can have two modalities.
Except for their video cards, which are B2C.
That's what he said.
Oh, there you go.
The most used robot today is the manipulator, manufacturing arms, and they are also pre-programmed. The computer vision algorithms, the AI algorithms, the control and path planning algorithms that are geometry aware, incredibly computationally intensive. We have made these CUDA accelerated. So we have the world's first CUDA accelerated motion planner that is geometry aware. You put something in front of it, it comes up with a new plan and articulates around it. It has excellent perception for pose estimation of a 3D object. Not its pose in 2D, but its pose in 3D. So it has to imagine what's around and how best to grab it. So the foundation pose, the grip foundation, and the articulation algorithms are now available. We call it Isaac Manipulator. And they also
How many things
just
can
run
he
on
announce?
computers.
How many things can he name Isaac?
We are
Yeah,
starting to do some really great work in the next generation of robotics.
maybe you can call
The
it
next
Ike.
generation of robotics will likely be a humanoid robotics. We now have the necessary technology, and as I was describing earlier, the necessary technology to imagine generalized human robotics. In a way, human robotics is likely easier, and the reason for that is because we have a lot more imitation training data that we can provide the robots because we are constructed in a very similar way. It is very likely that the humanoid robotics will be much more useful in our world because we created the world to be something that we can interoperate in and work well in. And the way that we set up our workstations and manufacturing and logistics, they were designed for humans. They were designed for people. And so these humanoid robotics will likely be much more productive to deploy. While we're creating, just like we're doing with the others, the entire stack. Starting from the top, a foundation model that learns from watching video, human examples. It could be in video form, it could be in virtual reality form. We then created a gym for it called Isaac Reinforcement Learning Gym, which allows the humanoid robot to learn how to adapt to the physical world. And then an incredible computer, the same computer that's going to go into a robotic car, this computer will run inside a humanoid robot called Thor. It's designed for transformer engines. We've combined several of these into one video. This is something that you're going to really love. Take a look.
It's not enough for humans to imagine.
I wonder what year that
We have
was.
to invent
I don't know, but he knew Jerry Mathers.
and explore and push
Tony
beyond
Dow,
what's
maybe?
been done.
Yeah.
We create smarter and faster. We push it to fail so it can learn. We teach it, then help it teach itself. We broaden its understanding to take on new challenges with absolute precision and succeed. We make it perceive and move and even reason so it can share our world with us.
Even reason? The loose definition of the word reason, I think.
This is where inspiration leads us, the next frontier. This is NVIDIA Project Grid.
Yeah, look at that thing.
Take a look at Boston Robotics when you get a chance.
A
I'm not sure how they differ
general
particularly because I don't know the
humanoid
technologies
robot
behind them,
learning.
but the Boston Robotics
The
robots are
group
more
model
advanced
takes
than what we're
multimodal
looking at here.
instructions and past interactions
They're
as
amazing.
input and produces the next action for the
And they're
robot.
very location
We
aware.
developed Isaac Lab, a robot
and
learning
human
application
aware
to train Groot on Omniverse Isaac
and
Sim.
responsive.
And we scale out with Osmo, a new compute orchestration service that coordinates
The
workflows
DJI
across
Osmo.
DGX
No, that's it.
systems
I was going to say that.
and
DJI
OVX
Osmo, it's the
systems for
combination of
simulation.
the
With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks. and emulate human movement just by observing us. This is made possible with NVIDIA's technologies.
Man, when they said this was going to be a 2-hour keynote, they weren't lying.
Deploy them
Yeah.
directly to physical robots. Connecting Groot to a large language model.
I love the names they're using, Thor and Groot.
Yeah, it's like the Marvel
That's
comic
exactly what they're doing. It's the
Can I give you a
Marvel
high five?
universe.
Sure thing.
The
Let's high five.
DC and the Marvel universes, I guess.
Can you give us
Well,
some
one of those he
tools?
called it the Jensen, so I think
Sure.
that was named
Check this
after
out.
him.
Oh, guess so. And Isaac is probably named after somebody, and I'm guessing there'll be a robot that'll come out as the Wally.
Designed for Groot, built for
No,
the
it's named
future.
after Ike Turner.
With
Right,
Isaac
I should-
Lab, Osmo,
I
and
don't
Groot,
think so.
we're providing the building blocks for the next generation of
I'll-
AI-powered robotics.
Yeah, that would be the robotic that
I was about to say an abusive robot.
Yeah, we don't want that. Oh, okay. Here we go.
Here are the robots.
This is like Variant, but instead of
Yeah,
bots,
these are
About the same
robots.
size.
Newton. That's right.
Now, if they start dancing and break dancing and stuff,
The soul of NVIDIA. The intersection of computer graphics, physics, artificial intelligence. It all came to bear at this moment.
Oh well,
The name
that's
of the
it.
project,
They've taken it a
General
long way.
Robotics 003. I know. Super good. Super good. Well, I think we have some special guests.
if they start dancing and stuff,
Do we?
Oh, there it is.
this is R2D2 clones.
Yeah. Cute.
Hey guys.
That
So I
one started
understand you
running.
guys are powered by Jetson. They're powered by Jetsons. Little Jetson robotics computers inside. They learn to walk in Isaac Sim. Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney. Amazing Disney research.
Those things are something.
They're
Come
cute.
on, you guys, let's wrap up. Let's go. 5 things.
He's moonwalking.
I sit right here.
He's coming. Oh, look at that.
Don't be afraid. Come here, Green. Hurry up.
Green is chilling.
What are you saying? No, it's not time to eat.
Yeah.
It's not time to eat.
He scanned them.
I'll give you a snack in a moment. Let me finish up real quick. Come on, Green, hurry up. Stop wasting time.
Green is not listening.
5 things. 5 things. First, a new industrial revolution. Every data center should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged, generative AI, which is going to create new infrastructure dedicated to
He's
doing
speeding
one
up because he wants to be on
thing
time.
only. Not
Mhm.
for multi-user
It's all right with
data
me.
centers, but AI generators. These AI generation will create incredibly valuable software. A new industrial revolution. Second, the computer of this revolution,
No,
the
third.
computer of this generation, generative AI, trillion parameters, Blackwell, insane amounts of computers and computing. Third, I'm trying to concentrate. Good job. Third, new computer creates new types of software. New type of software should be distributed in a new way so that it can, on the one hand, be an endpoint in the cloud and easy to use, but still allow you to take it with you because it is your intelligence. Your intelligence should be packaged up in a way that allows you to take it with you. We call them NIMs. And third, these NIMs are going to help you create a
His
new
numbering
type of
system is
application.
really bad.
Not one that you wrote
Hey.
completely from scratch, but you're going to integrate them.
I
like
just hope he
these.
ends it in time, and that would be
Create
great.
He said first,
We have
second,
fantastic
third,
capability
third.
Who's on
between
first?
NIMS,
No.
the AI technology, the tools, NEMO, and the infrastructure DGX cloud. in our AI Foundry to help you create proprietary applications, proprietary chatbots. And then lastly, everything that moves in the future will be robotic. You're not going to be the only one. And these robotic systems, whether they are humanoid, AMRs, self-driving cars, forklifts, manipulating arms.
Green
they
looks
will
like he
all
wants to get
need
out of
one
there.
thing. Giant stadiums, warehouses, factories. There can be factories that are robotic, orchestrating factories, manufacturing lines that are robotics, building cars that are robotics.
Damn.
These systems all need one thing. They need a platform, a digital platform, a digital twin platform, and we call that Omniverse, the operating system.
That's such a better way of
robotics
talking about it than the
These are
Zuckerberg.
5 things that we talked about.
Well,
today.
I'm the verse. It's
NVIDIA
just
look
it
like?
is their
What does
platform.
NVIDIA
Yeah.
look like?
They've
And
had
it's
that
like
for
the
a while, though.
GPUs.
Yeah, but
There is
now
an
you can
image
see
that I
what
have when I-
you know,
What they're
when
doing
people
with it.
ask
Yeah,
me
it's
about
amazing.
GPUs.
as Facebook
First,
did
I see
just
a bunch of
put
software
something out
stacks and
there
things like that. And
that
Oh,
didn't anything
I see
related
this.
to actual.
This is
That
what
was
we
people
announced.
think.
marketing crap.
Yeah,
This is Blackwell. This is the platform.
That's so big.
that is huge.
Amazing
That is really-
processors,
yeah.
NV-Link switches, networking systems, and the system design is a miracle. This is Blackwell. And this, to me, is what a GPU looks like in my mind.
Wow.
In my mind, it looks like his 4090 card, which I'll get on Wednesday.
Yeah, luckily
Listen,
it
orange,
won't be as
green,
big as what this
I
is.
think we have one more treat for everybody. What do you think? Should we? Okay, we have one more thing to show you. Roll it.
All right. This is how he gets off stage.
Is that artist guy coming back? He's back.
Looked like the guy from Toy Story with glasses.
Buzz Lightyear.
Buzz Lightyear with glasses, though.
Thank you. Thank you. Have a great GTC. Thank you all for coming. Thank you.
All right. Let me remove my man there, and that was. What'd you think? What give us some
Well,
thoughts?
I will say this: it was well beyond my technical expertise, but not beyond my imagination. And as a result of it, especially the latter part of it, which helped a lot by what he showed, the power of, let's say this, what he showed is transformative. I mean, genuinely,
Absolutely.
the world will change, and will change for the better or the worse, who can tell, but will change dramatically with what they've done, and not just that, but how they're thinking too, which is the other side of this, which is, I mean, let's say this, there was, to Paul Sweeney's point, there was a ton of stuff.
Yep.
But there was a lot of complete thoughts there, right? Not things in progress. There was some actual complete thinking about how the combination of this hardware with this platform, with this switch, et cetera, will lead to value in this area, whatever the area may be. And again, when he was in the weeds, I was trying to look up the acronyms he was using, the SOC, and I had no idea what he was talking about there, but I understood the gist of it in a way that made me see this is literally mind-blowing. And I guess, and last but not least, and then I'd love to hear what you're thinking, is, again, very in the weeds presentation, but at the same time, to your point in the private chat, a force of nature on the stage, right? The guy is it was a tour de force, right? The actual presentation, it was phenomenal what he went through and what he did and what Nvidia announced and how they're thinking about the world itself. So within that, way to go, Dan.
Actually, it's funny. Hyung has been commenting, and all of a sudden, they because I saw it on LinkedIn, they stopped coming in, and now they're like coming in all at once. So, sorry, we're out of sequence with that. But you know what? I think the most apparent thing is not only did they lay out not only a vision but a roadmap and tools that are already there and will be getting better. They got it feels like complete buy-in from some of the hugest enterprises working on some of the most challenging issues, and they seem to be the connecting force between all these disparate kinds of companies working on different kind of challenges, and they all have seemed to bought into a certain extent. I don't know, we can't go too far with it, but they all are working with these guys because of the vision and the roadmap and the pathway they put forth. And it's something that I haven't seen, that kind of unanimity or cohesiveness around one company's vision for a technology that seems to be very transformative. I haven't seen that in a long time.
Well, and to your point, the one thing they're doing, which is the best companies of the 21st century do, is they're thinking in terms of ecosystems and platforms. They're exactly, if you really boil it down to its 35,000 foot level, they're doing what the smart companies do. They're figuring out, all right, to build what we need to build, to your point, to achieve the vision, drive our mission here, we have technically we have a platform consisting of hardware and software, right, and the cloud itself, and services. And here's the ecosystem going to the partnerships and everything else. We need to accomplish this at the level that we want to accomplish. And also, here are the partners who could conceivably scale at the level we can.
Yeah.
Which is the other side. There's no small companies in there.
No, and the one thing that also is very apparent, we live in this bubble where the companies that we interact with, whether we're following or advising or whatever it is, it's still a very small little blip compared to all the other things that are going on. Because for the 2 hours that he was presenting, he touched on our little space of the world. 5 minutes, maybe 10 minutes.
Yeah.
All that other stuff he talked about was completely outside of our traditional areas, but they are so monumentally fundamental into the potential of what happens next. it was really a fascinating, like, a tour de force, and it was one guy presenting this. You know, we go to a lot of things. By the way, Paul, thanks for hanging out.
Hey, man, it's a pleasure. Say hello to Ireland for me.
Yeah, but it was so interesting to see we're used to seeing I don't want to say song and dance, but a lot of theatrics, a lot of, people coming in and coming out. And this is one guy with a couple of robots at the end, with some, demo videos. But it was a one-man tour de force about huge things. I got to give him a lot of, I mean, it's apparent how smart and not only smart, but how motivated now into what he's doing. And
Also,
the company, it comes through and goes through the whole company, it feels like.
He's astoundingly comfortable on the stage too, because, I mean, let's put it this way: almost every joke he made went over the heads of everybody there, and one of the robots didn't work. He just stood in the back.
Green was not going.
Green was just being really, really testy.
It must have been Draymond Green.
Right. That's right. I am not going to do any. All right. And then, as Alan pointed out in one of his comments, the video failed.
Yeah. It phased him a bit.
And Diana didn't work, but he just didn't even soldier on through. He just continued as if, okay, I'll just continue on and do what I have to do. And I'm not even going to gloss over it. I'll just move past it. And he just kept going without a single glitch. I mean, you remember in the earlier days before Larry Ellison got really good at speaking lately, he would get very annoyed when something wouldn't work.
Oh, yeah.
Right? Yeah, but this guy, nothing phased him.
No, it was just, and it was 2 hours, and it didn't feel like anybody was like, oh my God, will you please end? I mean, and like I said, how many keynotes have we been to where it's just the CEO and really nobody else? Usually they're bringing up other CEOs from their partners and giving them a chance. It was just one guy, and that's going to be a hard one to beat, since we're kind of at the beginning of the conference season, and we like to kind of rate these keynote presentations. I don't know. That's going to be a hard one to beat, and it's coming right out of the gate.
No, I agree, and the irony of it is a keynote that 70% of it I probably didn't understand any of. Right. But at the same time, I was still mesmerized by what was going on, because I understood we know some of his chips speak Wookiee.
He didn't speak Green. That was
right. Well, Green. Well, the one thing to be honest with, the one thing with Green, I agree with. I'm hungry.
Yeah. After 2 hours of sitting, I am
hungry. It's 6 o'clock, dude.
Yeah. So. No, I thought, I'm glad we did this, because
I am too.
I think, generally speaking, there's a lot of interest in what Nvidia is doing, but I think even in our industry, we wouldn't have done this last year, but we did it this year. And from the number of people who apparently were watching, there is a lot of interest.
Well, you know what we can do? We can probably, I think I told you, by sheer coincidence, a friend of mine who used to be a reporter on the Wall Street Journal, now runs corporate communications for Nvidia. Just came out of the blue like 3 months ago. I hadn't talked to her for about 6 years. And we're friends. I mean, we had a great conversation afterwards. We talked since. Maybe we can get somebody on from Nvidia on the Playaz to, kind of talk it through within the context of the world that we live in, so. Yeah. And
they got definitely people. I had been a few good minute EPs a couple of years ago.
You remember one that you particularly thought would be like real communicative in our universe?
Well, unfortunately, I think he's on sabbatical.
Okay. All right. Well,
we'll find somebody, but because they're doing so many interesting things, even within our realm. I think is going to be great to have somebody come on and really start focusing on, and just seeing the impact of what they do on the other companies in our industry.
I mean, it was. Look, it was worth the 2 hours, which I rarely say about any keynote.
Right.
Usually it's, aren't they supposed to end now?
Yeah. What
Like,
is,
that's usually,
come on now. You know, what's
come
going
on, you're over by 20 minutes. You're over by 1 minute.
Yeah. Yeah.
uh,
But no, this was really interesting. Now I'm gonna be going to Summit. You're gonna be out doing an advisory day at Sugar.
Right.
If I think the keynote is on the 26th. Are you
I think that's the day I'll actually be traveling back.
Oh, okay. So we probably
Yeah.
won't be able to do a
Watch party for Adobe.
what? No, but
Well,
I'll be there getting a few good minute
Yeah.
conversations. So
that should work. That'll be great. That'll be, so everybody, a few good minutes with Brent Leary and people from Adobe.
well, I know one is gonna be Doug Anderson.
Oh,
They already set it up.
We love Doug Anderson,
Yeah,
man.
so that's gonna be good.
He's a regular. He's
But-
awesome.
But before we get to that, guess what? Thursday. The great debate is back, folks. And we got
and no question mark necessary.
yeah, matter of fact, why did I even do that? Let's go to this one.
All right.
I'm
Try it
I'm
one more
bringing-
time. And Thursday, the great debate. There we go.
No question marks. This is going to be good. We got Mr. Stutz, Mr. Kolsky, the Brohammer, and Cheryl Kingstone. All of them been around, know their stuff inside and out from a variety of perspectives. But the best part is they don't mind sharing their opinions at all.
No, and they don't mind sharing them no matter what the other three think.
No, which is going to be great for us.
Yeah. This is one of those where Brent and I get to sit back and watch,
Yes.
right? Other than ask the questions that they have to talk about.
Oh, matter of fact, so we have to come up with 3 topics
Yeah.
for them to discuss. So this is where you guys come in. We'd love for you to leave some in the comment section, topics that you think it would be great for them to talk about, the back and forth. Maybe they'll make it in, maybe they won't, but it'd be really cool if we're able to get topics right from the community that we can deliver to these folks to discuss. So
It would be awesome. So, folks, get in. If you can't get them in the comments now, but you're hearing what we're saying, we'll put up both Brent and I will put up on our own pages and on the Playaz page saying, hey, give us topics, kind of posts so you can give us topics.
we want topics.
That's what we're asking for. Topics.
Yeah.
Topics, not
No.
tokens, topics.
No. And you know what I want now? Dinner.
Yeah,
So-
me too. I'm hungry.
So
Hungry.
since this is an official Playaz episode, we could just say, hey, I'm Brent.
I'm Paul.
And yeah, we're the CRM Playaz, but we
We
don't
don't
give
get
you
many till
no many
no, not till Thursday.
only on Thursdays. So we'll see you then.